Previously, we went through looking at how we assess risk, in other words, what risk amounts to. As if you will recall, risk is really the probability of a loss or a negative outcome. On this presentation, we want to talk a little bit about how we manage risk. There's 5 different things we want to mention here. Risk can be managed through diversification. Risk can be managed through marketing alternatives, flexibility within our production systems, credit reserves, and insurance. These are the 5 things that we want to talk about. Now, diversification is really something that really we probably see less diversification these days than we used to in the past in terms of agriculture. Farms and ranches became more specialized to where they tended to grow or produce one particular product or 2 particular products. Back in the 30s and 40s and 50s, you often saw a farm would have several enterprises and some producing crops and maybe grain, cotton, forages, and then have some livestock. So there was some diversification across enterprises. And there's some advantages to diversification. We became more specialized as we developed newer technologies. And so we become where many producers just produce one enterprise, maybe it's all cotton. They're geared up just to produce that one enterprise. But we're beginning to see more diversification come into play because diversification is one of those means of reducing risk. And so it may be possible to reduce your total variability of returns, which is what we call business risk, by combining several assets or enterprises. These can be oftentimes put together without really sacrificing an expected return. Now, holding a combination of investments is called diversification. You may have looked at what's called portfolio theory or a portfolio of investments or a combination of assets or enterprises or investments that we would consider to be a portfolio. The point with a portfolio is that some of those different investments may have different expected returns and may have different standard deviations of those returns. And if we combine those in such a way to where they tend to offset each other, is that if we have a loss in one particular area, it is made up with a gain in another area. And so that's why we look at portfolio theory when we're looking at diversification. So let's look at an example of diversification. You've got an investor who's evaluating 2 farm units. One's located in the Corn Belt and one's located in the Great Plains. 2 different locations, 2 different cropping systems. Each farm has an expected return on assets of 20%, and each farm has a standard deviation of returns of 10%. So in other words, from the standpoint of expected returns and the variation of those returns, each one of those farms is considered to be equal. Therefore, an investor would be indifferent between the 2. It would not matter from the investment standpoint which farm that he chose, because one is just like the other one as far as returns. However, since the 2 farms are located in different regions, they have different mixes of enterprises, we could combine these 2 investments in such a way that we could take advantage of the differences in the location, and what we're really taking advantage is of the differences in the correlation of returns to manage risk. Now, the portfolio model, when we look at that, we want to look at 2 things with regard to the portfolio model. One is the expected return, and the other one is going to be the variability of returns. The portfolio's expected return is nothing more than the weighted average of the individual components, the expected returns of the individual components of that portfolio, weighted by the percent that that component makes up that portfolio. So if we look at this equation, our capital RT is the expected return for the portfolio, and that's equal to the expected return for investment one times the proportion of the portfolio that is investment one, plus the expected return for investment two, or little r2, times P2, which is the proportion of that portfolio that is in the second or the second investment. So it's just a weighted average of the expected returns of the components of the portfolio. Now, when we look at a portfolio's total variance, in other words, we're looking at its variability, it's a little more complex because a portfolio's total variance is the sum of the individual proportional variances plus or minus the covariance. So if we look at this, we have sigma big T squared, which is the variance, if you remember your terminology from statistics. And it's equal to the variance of investment one, which sigma squared, times the proportion of investment one within the portfolio squared, plus the variance of investment two times the proportion of investment two in the portfolio squared. Then we add another component. We add to that this term, 2 times the proportion of 1 times the proportion of 2 times the covariance, or in other words, the correlation between the two investments in terms of their return, times the standard deviation of 1 times the standard deviation of 2. So it's we're looking at the weighted averages of the portfolio variances, but then we're looking at the correlation or the relationship between those two investments in terms of their variability. So let's look at an example here. Well, quickly, if we look at these different components that we have there, RT is an expected return, little r, which could be 1, 2, 3, or whatever, is the expected return for each investment. PI is the proportion of that investment that's in the portfolio. Sigma T squared is the portfolio variance. Sigma I is the standard deviation for each investment. And C is the correlation coefficient between returns for each investment. Okay, let's look at an example here. We assume that the proportion invested in each of those farms is 50%. And the correlation between returns is 0.5. What would be the portfolio expected return in the standard deviation? Now keep in mind the correlation here is 0.5, which means that if returns go up in one, increase in one farm, they're going to increase in the other farm, but not perfectly with each other. In other words, they're going to go in the same direction, yes, because it's a positive correlation, but not at the same proportion. So if we looked at the expected portfolio return, it would just simply be 0.2, which is the 20% return in farm 1 times 0.5, which is the proportion, plus 0.2 times 0.5. We add those together, we get 0.2. In other words, the expected return for the portfolio would be the same as it would be if we purchased one farm or the other farm. If we have both of them at 50% apiece in the portfolio, they have the same expected return of 20%. Now, as we calculate the portfolio standard deviation, it gets a little more complicated than the portfolio return. As you recall, we had the expected return for each one of those farms was 20%, the standard deviation of return was 10% for each farm. So we could express that as 0.1, which would be the standard deviation. So if we apply this to the formula, the overall variance of the portfolio would be the standard deviation for one farm, 0.1 squared, which makes it the variance, the proportion 0.5 squared, the same for the other farm, 0.1 squared, 0.5 squared, and then we add the last component, 2 times the proportion for each farm of 0.5 times the correlation coefficient of 0.5 times the standard deviation of 0.1 for each one of the farms. So when we add those up and we sum all of this, what we find is that the portfolio variance is 0.0075. The standard deviation is the square root of that, or 8.66%, or 0.066. You'll notice here that the portfolio standard deviation is less than the standard deviation of each one of the components of the farms within the portfolio. The standard deviation for each one of the farms for their returns was 10%. The standard deviation for the portfolio is 8.66%. The return, as we calculated for the portfolio, was 20%, which was the same as each individual farm. So what we've been able to do here is we've been able to get the same return, expected return of 20%. However, we have lowered the standard deviation, or the variability of returns, because we are combining two components here that have a correlation coefficient that is not perfectly correlated. In other words, a 0.5. So the key component with regard to constructing a portfolio that reduces risk while maintaining a level of returns is that correlation coefficient. In other words, selecting components within that portfolio, or enterprises, if we're looking at enterprises or investments that have are not perfectly correlated. And so therefore they're able to offset, or in other words, we start mitigating some of the risk. Now the correlation returns, the value of the correlation coefficient can be anywhere between a -1 and a +1. If it is -1, it means that the two investments are perfectly opposite correlated. In other words, if one went up 10%, the other went down 10%. If it is 1, it means that they're perfectly positively correlated. So if one goes 10% up, the other one goes 10% up. And then whatever's in between. And you can have components that are negatively correlated, but they're not perfectly negatively correlated, or positively correlated, but not perfectly positively correlated. So let's look at what happens to our equation here for variance by different values of the correlation coefficient. If we have a perfectly negatively correlated correlation coefficient, that last piece over there becomes a negative. So in other words, that's going to be pulling out variability. If it is perfectly zero, in other words, there is no correlation, which to be honest, you probably never find a zero correlation. But if you have no correlation, it's just a weighted average of the variances. If you have a perfectly positively correlated, then that final component over there becomes positive. And so there's a difference between whether if we have a negative correlation, we're taking away variance. If we have a positive correlation, we're adding to variance. But the question is, where are we at within that -1 to a +1? So in other words, if we had that same example we had a while ago, if we had instead of the uh, correlation coefficient being a positive 0.5, if we had a perfectly negatively correlated coefficient, in other words, -1, what you would find is there would be zero variance. In other words, you would have taken out all of the risk. So if you have a perfectly negative correlated uh, coefficient, then you take away all the risk. If it is zero, if we had a zero correlation coefficient, or in other words, they're not correlated at all, then our risk would have been 7%. And if we had a perfectly positively correlated, in other words, where C was 1, then it would be 10%. And so the difference here is all the way from zero, if you have a perfectly negatively correlated coefficient, to a perfectly positively correlated. You see that there's this range within there that we can use to mitigate risk. Now, the risk return trade-off, which we've talked about a little bit before, is what we're looking at here is a combination of components within a portfolio that give us the highest level of return, in other words, on the vertical axis, for the lowest level of risk on the uh, horizontal axis. And we can define these by combining them and looking at how they can be combined, different components of the portfolio. And what that line there that's defined by A, D, G, and H, what that defines is what we call the efficient frontier. In other words, it is the combination of components within that portfolio that give us the highest level of return for a given level of risk. So in other words, if you just look at A, B, and C, if you were selecting which portfolio would you rather have, you would certainly want to have A, because A gives you the highest return at the lowest level of risk. A is better than B because B gives you the same return but at a higher level of risk. A is better than C because it gives you a higher return at the same level of risk. And so we can define what we call these efficient frontiers by looking at various combinations of enterprises. Now, what is termed a risk efficient set of portfolio is composed of portfolios that minimize variance for different levels of expected return. The portfolios in the preceding graph of the risk return trade-off illustrates the concept of what we call risk efficiency, or what we're talking about here, efficient portfolios that give us that highest level of return at a given level of risk. If we go back to that, portfolio A dominates C and C and B. So if we look at portfolios A, D, G, and H, as we look up the across that efficient frontier, they represent portfolios that lie on the risk efficient frontier, which gives the highest return at a given level of risk. Now, when we talk about enterprise diversification in agriculture, we're talking about diversifying among several farm enterprises, even between farm and non-farm activities is a traditional approach to risk management in agriculture. In other words, you may have more than one enterprise within the farm. You may have some agricultural enterprises and some non-farm investments. So this gives you that diversification between enterprises or investments. Now, the type of diversification is based on the premise that there is a low or negative correlation of returns among some enterprises that can stabilize returns over time. A good example of this would be in our area here, we're looking at the possible enterprise of grain and cotton. Grains and cotton, whether it be grain, sorghum, or corn, or cotton, the weather patterns that give you the best results in terms of yield are oftentimes a little bit different. Cotton likes to have more of a hot, dry summer, if you will, versus a corn and grain would do better with a cooler, wetter summer. So you can, by diversification here, you can sometimes diversify and take advantage of any particular weather pattern that you might have. Same thing with prices. You may have different relationships there with regard to prices. And so that's why that we do see some uh, movement towards more diversification of enterprises. So a consideration with enterprise diversification is the loss of efficiencies and returns that may be derived from specialization. Again, when we're talking about diversification of enterprises, we may lose some of the efficiencies that we have with specialization in terms of the types of equipment that we need to have. Sometimes another one of those issues that can come to play here that is some of the chemicals and herbicides that we use. There may be some conflicts there sometimes between those two different crops. So you do lose or potentially lose some of the advantages of specialization whenever you diversify. But you can gain by doing that. You can gain some efficiency relative to risk.